So we're gonna wrap up chapter 14 with some trigonometric functions. Hopefully, it won't take too long to get through these. It's going to be a lot of repetition, and then we're going to build on to these more when we start doing specific right triangle trigonometry for the majority of chapter 15. Okay, so something I want to go over, just kind of really in depth. I want to make sure that you kind of understand this relationship here. So we are dealing with points in a coordinate grid. We're dealing with angles in standard position, okay? And we expand on the angles in standard position, and we look at these trigonometric ratios. Hopefully you've seen these ratios before in the past. We'll go over them again. It's a big topic in geometry. And so what we're doing is we're looking at a specific point on the coordinate grid. Any point in the coordinate grid, x, comma, y, okay, other than the origin. And we're going to say that that point is going to be on the terminal side of an angle in standard position. Terminal means that's where it ends, okay, that ending side. And so if I have a point here, so let's do this in right paint right here. So if we have this point right here, any given point, and it's on the terminal side of the angle in standard position, we have this some amount of rotation right here. Okay, some amount of rotation. We use the Greek letter theta to represent the measure of that angle. Okay, so that's what that little zero with a line through it is. That's theta. Okay, that's the measure of any angle. So the distance from the origin to this point is given by our distance formula. Okay, so our distance formula, we'll break this down a little bit. Distance formula, square root x1 plus y, or x1 plus x2. I'm sorry, x minus. Okay, that's the point. X minus squared, and then we've got x1 y1 minus y2 squared. That's our distance formula for anything, ever since the beginning of algebra. Okay, distance formula. Distance between 2 points, the difference between the x's, the difference between the y's, square them, add them, square root. Okay, that's the distance formula. But when we're looking at points in standard position, they all share a common point, the origin. Okay? Well, if one of our points is the origin, that means that x2 and y2 are both 0. Well, if we subtract 0, does that change anything? No. So essentially, I don't need that. And so what happens is we end up reducing the distance formula down to this. Okay? So that's our distance formula, measuring distance from the origin. Okay? Now, where the distance formula comes from is from right triangles. If I have 2 sides of a right triangle, what do I use to find the third side of a right triangle? The Pythagorean theorem, which is a squared. Yeah, the part at the top where it says trigonometric. Okay. So our Pythagorean theorem, a squared plus b squared equals c squared. That's the distance formula. A and B represent the 2 horizontals, or the 2 non-hypotenuse sides, the 2 legs. Okay? Instead of A and B, we could just have x and y. X squared plus y squared. And instead of C, we use R to represent radius, like the radius of a circle. Well, if I want to solve for R, and I isolate it, how do I get rid of a square? Square root it. And that's where the formula comes from. It just comes from the Pythagorean theorem. A squared plus b squared. We change a and b to x and y. We change c to r. And then we just isolate r. So that's where this distance comes from. But it is the Pythagorean theorem in a nutshell. Okay? So you don't really have to memorize a new formula if you don't want. It's Pythagorean theorem just rewritten a little bit. Okay? So we have this relationship where the radius is the square of the sum, or the root of the sum of x and y. So we have trigonometric functions when we're relating them in the coordinate grid. Okay? When you first learned about trigonometry, you learned about the functions sine, cosine, and tangent. Okay? Hush, it's my favorite stuff. Sine, cosine, and tangent, we related them in a triangle with opposite side, adjacent side, hypotenuse side. Okay? So you may remember, and we'll go in more detail about this later. If you don't, it's not that big a deal. Okay? Sine of an angle is the ratio of the opposite side over the hypotenuse side. Cosine is adjacent over hypotenuse, and then tangent is our opposite over adjacent. Tangent of theta. Okay? The mnemonic, SOHCAHTOA. Okay? Which is great when we're given a triangle just in isolation. Here's a triangle, right triangle, here's some sides. We want to find some trig stuff. And we'll be doing more. We'll be doing that later. But right now, what I want you to notice is kind of there's a little bit of a change. Okay, we're not using opposite and adjacent because we have a point in the coordinate grid. We're using x, y, and r to define these functions. Okay? So, when we look at our original triangle, and we're looking at our angle within inside of our triangle, that's this little one right here. Okay? That little acute angle in our triangle. Alright? And I want to look at the sine of angle theta prime. Okay, just to differentiate it. What side is opposite of that angle? Y. It's right here. Opposite is y. So if I'm looking at opposite over the hypotenuse, in terms of coordinate grid trigonometry, it's actually the y, and then my hypotenuse side is the r. That's opposite my right angle. So opposite's actually y. Hypotenuse is r. What's the adjacent side? X. So when we're looking at cosine of theta, instead of adjacent over hypotenuse, we have x over r. It's the same concept, the same ratio. We just use something else to describe it because it's in a different context. Okay? So these are the 6 trigonometric functions. We have sine of theta, which is the equivalent to the ratio of the length of side y over the radius. Cosine of theta, which is equal to the ratio of the length of side x over the radius. Tangent is y over x. Why does it state that x cannot equal 0? Why specifically do we think it says that x? What happens if 0 is a denominator? Okay, so tangent cannot have an x value of 0. So if we ever have an angle of rotation where our x value is 0, tangent ends up being okay. Cosecant is the ratio of r over y. Notice it is the reciprocal of sine. Okay, so cosecant is the reciprocal of sine. Secant, r over x, is the reciprocal of cosine. And cotangent, x over y, is the reciprocal of tangent. Okay, so those are our 6 trigonometric functions. All right, so we're going to start off with finding a lot of those, given some criteria. So there'll be a lot of find the 6 trigonometric functions. Find, sine, cosine, okay? And then we're going to continue to build and build and build. All right, so right now we're just doing some ratios. So the terminal side of angle theta in standard position passes through the point 8, 15. We want to find the values of the 6 trigonometric functions. So the first thing I do recommend is draw a triangle. Draw that angle in standard position. And the easiest way to do that is first figure out where is your point located. If I have the point 8, 15, what quadrant am I going to be in? In quadrant 1. I will be 8, positive 8 on the x-axis, 15 on the y-axis. I'm just plotting it somewhere over there. It doesn't need to be perfect. I just need to mentally know what quadrant I'm in. Okay? So that's what's really important. So I have some angle that rotates some amount and ends up at the point 8, 15. So here's my angle rotation, there's theta. So there's my angle in standard position. We started on the x-axis and we rotated theta degrees until we had a line that passes through the point 8, 15. So now what we want to do is we want to build a triangle off of this. The easiest way to do that is take your point and drop it straight down to your x-axis. And then we've got a right angle. So now let's look at the two legs of our triangle. If my point extends to here, and I come straight down, on my x-axis, how long is that length? How long does that length have to be on the x-axis in order for it to line up with the point 8, 15? 8 is the x value. So the point 8, 15 says that this leg is going to be 8 units long. Okay? Now, looking at the leg on the y-axis that runs parallel to the y-axis, how tall does that have to be in order to get up to the point 8, 15? 8, 15. Okay? So your point, your ordered pair, gives you the two legs of your right triangle. Well, and then we want to find the radius. We want to find the distance on from the origin, which is just the hypotenuse. So you can use your radius formula, you can use your Pythagorean theorem. They're the same. So it doesn't matter how you look at it. We'll just use radius because it's already got everything kind of isolated for us. The square root of the sum of the squares of x and y. Okay, so we take x, we plug it in. We take y, we plug it in. 8 squared plus 15 squared. And then we evaluate it with 8 squared. 64 squared. 64 plus 225. 289. Okay? Can we square root 289? So, now we have our radius, or our hypotenuse, 17. So now we have all three sides of our right triangle, which is all the information we need to get our 6 trigonometric functions. So we're going to go through these. Okay, so let's start with sine of theta. Okay, sine is our y value over our radius. What's our y value? 15. What's our radius? 17. So 15 over 17. Can we simplify that fraction? No. Then we're done. That's all we're doing. We're just writing the ratio of the fraction. Sine of the angle theta is equivalent to the ratio of 15 over 17. Cosine uses which side? X over r. What is our x? 8 over 17. Can we simplify that? No. No. Can we leave it alone? We're done. Tangent. We're going to have y over x. 15 over 8. Okay, so there's our first half of our trigonometric functions. So then we have the second half. Okay, now, as long as you can remember which ones are reciprocals to each, it makes it really, really easy. Okay, but the reciprocals are often confused. You have to remember, it's kind of a weird switch. Sine, its reciprocal is cosecant. Cosecant. Sine and cosecant. CSC. Sine of theta and its reciprocal cosecant. So if sine is 15 over 17,
17 over 15.
Ooh, it sounds so much easier than last year.
Don't worry, it'll get harder.
It's not.
Stop.
Chapter 14 won't get any harder. Chapter 15, that's where we use this. Alright? Cosine, its reciprocal, is secant. So what's secant theta? 17 over 8. And then tangent, that one's easy. Its reciprocal is cotangent. 8 over 15. Cotangent of theta is 8 over 15. Okay, so there's our 6 trigonometric functions of angle theta. Alright? Questions so far? Pretty straightforward. Okay? Let's do it again. Terminal side of angle theta in standard position passes through the point -3, -4. We want to find the 6 trigonometric functions of angle theta. What quadrant are we going to be located in with the point -3, -4? Where's the third quadrant located?
To the bottom
Good.
left.
You guys are so smart. Okay. So we have an angle, okay, here for theta. All right. We want to go ahead and do our triangle. So we're going to draw it towards the x-axis. Always towards the x-axis. I'm going to emphasize that. It's always drawn towards the x-axis. Very, very important.
Not away from.
We always draw this line, the vertical line, towards the x-axis. We do not want to make this one. But if you switch it, then you're switching all your trigonometric functions. Sine becomes cosine, cosine becomes sine. You get everything swapped.
Would you ever do that to us?
You would do it to yourself if you drew it wrong.
Okay.
That's why I'm emphasizing when you draw your triangle, always make sure that you're connecting it to the x-axis. Okay? All right, so what is the length of this leg here? -3. That negative is important because we're going to the left. -3. And then the length of my vertical leg? -4. That part is also important. So your legs can have negative values. Okay? However, the radius will never be negative because we always end up squaring the legs. We always end up squaring the legs, and we have to take the square root of negative. So our radius will always be positive. Yeah, I do a lot of those in the notes because they're easier. They will not always be Pythagorean triples. So if you have a radical that you can't take the square root of, just simplify it. Simplify the radical. Leave it as a radical. Unless they tell you around, but probably not. All right, so sine, cosine, tangent. What's the reciprocal of sine? Cosecant. What's the reciprocal of cosine? Secant. What's the reciprocal of tangent? Cotangent. Okay. All right, so sine is going to be what ratio? What's y? What's r? Oh, -4 over 5. What about cosine? -3 over 4 over 5. There we go. Tangent, which simplifies to what? 4 over 3. Tangent, positive. Sine and cosine, positive. Okay, cosecant. Yep, which we would just simplify to be -5 over 4. Secant, Yep. Which we would simplify to be negative 5 over 3. And then cotangent. 3 over 4. Pretty straightforward, right?
Yeah.
You just need to make sure that you're keeping track of your signs. And that's all based on making sure you're in the right location. Okay? And especially as we get further and further, a lot of the numbers we're going to be dealing with for these ratios will be very, very repetitive. The major difference will be positive and negative. So you need to make sure you're paying really close attention to that. All right? Now, this one's set up a little bit different. So we want to find the 6 trigonometric function values of the angle theta in standard position if the terminal side is defined by this line. Okay? Defined by that line. So what we want to do is we want to kind of figure out where that line is. Well, based on what we're doing, we know it has to go through the origin. So really all I need to do is figure out what its slope is. And figure out the slope of this line so I can figure out some of the points on that line. Okay? So let's start with our grid. Okay? One of the easiest things may be just get it in slope-intercept form. Okay? So if I wanted to rewrite x plus 2y equals 0 in slope-intercept form, how would we rewrite that? Subtract the x, then what? Divide by 2. Okay? So y equals negative 1/2 x. Okay? So we can see that it goes through the origin because our y-intercept is 0. Okay? And so we're given our slope, negative 1 over 2. So our line goes down 1, right 2. And so we have this point, negative 1. Went down 1, right 2. Okay, based on my slope. I could also go up 1, left 2 to get the point negative 2, 1. That's where that comes in, is important. X must be greater than 0. So this line continues forever in both directions, but in order for it to be an angle in standard position, I can't have it go both directions. So this says x has to be greater than or equal to 0, which means our line's only going to stand in the positive x direction. So that is the direction of my angle. And we can ignore all of this over here. So our angle is determined by this line. There's the terminal side. Here's the initial side. And we go all the way around here to get our angle. Okay? So we're going to go ahead and we just pick a point on the line. Well, the one we got from our slope is probably going to be the easiest one to use. It's given. So we're going to use the point 2, negative 1 to finish off our triangle. Use the point 2, negative 1 for your triangle. You can use any point on that line. It does not matter. You will get the same value. The only difference is if we picked a point further down the line, we're going to have to more simplify more. That's it. It's the only difference. Because the ratios will be consistent the whole way down this line. Okay? Because the measure of this angle doesn't change no matter where I draw my triangle. The angle is always going to be the same. So if we have bigger values of x and y, we're just simplifying larger values to get to the same simplified ratio. All right? So what's our x value on this triangle?
2.
And our y value?
1.
Okay? So we can go ahead and use our ratio, or our formula to find our radius. 2 squared plus negative 1 squared. So our radius is just the square root of 5. Okay? And we're going to leave it as the square root of 5. So, Pythagorean triples this time. Okay? So our radius is the square root of 5. Now we have all the information we need for our ratios. Sine of theta. What over what?
Y.
What's y?
Negative 1 over 15.
1 over the square root of 5. Okay?
It looks like a 15.
So we're going to we cannot leave radicals in denominators, so we're going to need to rationalize.
That's so that would be negative.
Yeah, so we're just going to multiply by the radical. So negative 1 times negative root 5 is negative root 5. Root 5 times root 5 is 5. So we always rationalize our trigonometric functions. But don't get rid of this. Don't get rid of this, okay? Leave that there because we're going to use it later. All right, it'll make our life easier. Cosine. Cosine is 2 over root 5. So when we rationalize it, 2 root 5 over 5. And tangent. No rationalization necessary. There's no radicals in that. So negative 1 over 2. All right, what's our reciprocal for sine? So we have cosecant of theta. We can write the reciprocal. We could either look at this, root 5, or negative root 5 over 5, write the reciprocal and then rationalize it again. But usually, it's a whole lot easier to go back to this one. Because when you write the reciprocal, you don't have to rationalize it again. You're already taking the radical out of the denominator. So negative 1 over root 5 becomes root 5 over negative 1, or just negative square root of 5. No rationalization necessary. What's our reciprocal function for cosine of theta? What's our reciprocal for cosine? Root 5 over 2. Root 5 over 2. We just went ahead and took that and wrote our reciprocal. And then for tangent of theta, the reciprocal function is cotangent, and our reciprocal of tangent is negative 2 over 1, just negative 2. So a lot of repetition. Pay attention to the details. They're easy to lose if you're not careful. Any questions on that? Okay. Find the values of the 6 trigonometric functions for an angle of 90 degrees. Okay. Where's 90 degrees located?
Right angle.
Which one? The first one, right? It's that right angle. So my angle in standard position would be there. Okay? Okay, so there's theta. Angle of 90 degrees. So again, we can pick any point on that line to get our x and our y. Okay? So, literally, give me any point that would be on this line, on the y-axis.
0,
0, 1, 0, 5, 0, 20, 0, 5,372. Okay? All the x values are 0. Just pick a y value. Okay? Now, x is 0. Y is 2. Okay? I can't really draw a triangle because if I try to go straight down, I just have a line, right? There's no triangle there. So we still need our radius. Well, how far is that point from the origin? 2. 2 units up. 2 units away. Our radius is 2. So we don't need to draw a triangle when we're on the axis. We call these quadrantal angles. They're on the axis. And we can't draw a triangle with a quadrantal angle. But we can still write our ratios. Sine is y over r. What's y? What's r? So if we're doing y over r, 2 over 2 reduces to what? 1. Cosine is what? 0 over 2, which equals 0. tangent is what? 2 over 0, which equals what? Undefined. Remember that from earlier? That's why we end up getting something with an x value of 0. We're on the y-axis. Our x value is 0, giving us an undefined tangent. Okay? What's the reciprocal of sine? Cosecant, which will equal 1. Reciprocal of 1 is 1. Reciprocal function for cosine is secant. What's the reciprocal of 0? Undefined. The reciprocal of 0 is undefined. Because we take this 0 over 2 and then rewrite it as 2 over 0, now it's undefined. So 0 is the only number with no reciprocal. Its reciprocal is undefined. So now working backwards, if I have the reciprocal of tangent, which is cotangent, what's the reciprocal of undefined?
0.
0. Okay? Our quadrantal angles follow that pattern. They're either going to be a 1 or a negative 1, depending on which axis you're on. A 0 or undefined. That's it. That's what they'll all be. Okay? If you're at 90, 180, 270, or 360, all of your trig functions will be one of those 4 numbers. Okay? Which is delineated by this chart down here. Okay? So real quick, we'll go with this last one here. So negative 3, 0. What axis is that located on? On the y. It's on the x-axis. Okay? Over here to the left. Negative 3, 0. Okay? So x is negative 3. Y is 0. What is r? 3. Okay? The distance from center to there, or from origin to that point, is 3. So we can write all of our ratios based off of this. So sine is y over the radius. Cosine is x over the radius. Tangent is y over the x. Reciprocal for cosecant, undefined. Reciprocal for secant, still negative 1. And reciprocal for cotangent is also undefined. Yep, those are the only options we have. Positive 1, negative 1, 0, or undefined if we're located on the x-axis or the y-axis. Any of our quadrantal angles. Okay? So this chart kind of goes through and you can see that tangent, cotangent, secant, and cosecant, those have options to be undefined because those have x or y in our denominator. Those are the only ones that can be 0. Our radius can't be 0. And then everything else is either a 1 or a negative 1 or a 0. Now, last thing is real quick. When we move on a little bit further in the unit and into the next unit, when we're actually kind of evaluating some of these angles, you need to be very, very aware of what your calculator is in, the mode. All right? And also, if you're not sure whether something would be defined or undefined, that kind of our calculator will help us evaluate this. But up here at the top, see where it says radian? That's the default mode for your calculator. So if you ever reset your calculator, as you should be, that's going to change back to radians. So whenever we're doing angle measurements and it's given in degrees, we have to make sure that it's in degree mode. Otherwise, it's assuming that the value is a radian measure, which is something vastly different. Okay? And we'll be using radians later. But if we ever need to change it back, we can click on mode, and that third option down says radians in degrees. Or I guess the fourth option down. Third option. So we go down over to degree, highlight it, press enter, and we can see it changes up here. And now it's in degree mode. And then if we ever want to evaluate our trigonometric functions, this won't work for most of them because we have, fractions and different things, but you can kind of see how when we do sine of 90 degrees, if I could actually click the right numbers. Okay, we get 1, but if we try to do tangent, where we know it's undefined, we get a domain error. Okay, so if you see error domain, it's usually a big hint. Oh, it's undefined. I can't evaluate it there because it's trying to divide by 0, and my calculator says, nope, you can't do that. So we get that error when we try to evaluate tangent of 90. Yeah, that's last slide, right? All right, we did it.